Hello, everyone, and welcome. We're going to get started in just a minute. Thank you all for taking your time today to join us for this webinar from SingleStore on Distributed SQL, a primer on query processing. Today's webinar, we're going to focus on how you can use query processing with Distributed SQL to speed up your ingest and your pipelines, your queries, and have low latency results on SingleStore. My name is David Jakobovich, and I'll be your presenter for today's webinar. The topics today will be available for you in on-demand replay as well. So be sure to always check out singlestore.com/events to check out all of our webinar recordings. For today's agenda, we're going to focus on an architecture overview about SingleStore and our latest release from June 2021, in addition to diving deep into query processing with techniques such as Skiplists and Hash Indexes, followed by some DDL commands that you'll be able to hands-on practice with our live lab, spinning up your own SingleStore Managed Service dedicated cluster. We'll then have some Q&A, so feel free to share any questions that you have in the chat anytime. I'll be sure to get through them both live and at a dedicated Q&A session at the end of today's webinar. To start us out, as a reminder, if you're new and returning to the SingleStore family of products, our SingleStore Managed Service is available on the cloud. And today we offer up to $500 of free credits for you to practice with SingleStore Managed Service. You can sign up at the URL here, which is singlestore.com/managed-service-trial. For today's lab, we'll also be using the SingleStore Managed Service, so if you're new to the product, be sure to sign up with your account so you can join us live with the labs. There's some other great ways to learn about the SingleStore product. We have our docs at docs.singlestore.com, our form with the community at singlestore.com/form, our YouTube series on youtube.com/SingleStore, our training at training.singlestore.com, which includes free developer training and admin training on both our SingleStore Managed Service and SingleStore DB products. Today, we also have exciting badges for course completion that we can offer to you when you complete those trainings. So be sure to get learning on SingleStore. And for any questions that you may be experiencing at the startup and enterprise level, we have an open source knowledge base at memsql.zendesk.com, where you can see some of our most frequently asked questions that our database as a service and support team have replied to help you be more successful with implementation and scaling of your SingleStore clusters. So with that, we're going to get started here on today's topic. I'll share some background on SingleStore first as a refresher. So the world today is data-driven, and by being data-driven, there is an increase in complexity to access data and interpret data with insights. SingleStore here is to solve for the pain points of slow responses for meeting mission-critical SLAs, reducing the costs of a rising total cost of ownership, and helping for live concurrency with tens and hundreds of thousands of users. SingleStore is the unified database for fast analytics on any data, anywhere. And with our 7.5 release from June 2021, we released several exciting new features, including limitless storage, point-in-time restore, acceleration of our query engine, separation of storage and compute, and a lot of exciting new features to allow you to have a database for data-intensive applications. That's SingleStore's sweet spot. SingleStore sits at the crossroads of ultra-fast ingest, super low latency, high concurrency, and ultimately fast analytics. This is why companies such as Uber, Dell, Verizon Wireless, and others support our database to help scale their efforts in the marketplace. Adopting SingleStore is possible really through three core value adds, either building modern applications from the ground up with your SingleStore database as a system of record, augmenting traditional databases and data warehouses with SingleStore's suite of products, either through our database or managed service, and modernizing with digital transformation to consolidate and replace legacy data stores, specialty databases, or other Hadoop systems. Today, SingleStore is proud to announce our version 7.5 of our product with SingleStore Universal Storage. Our June 2021 release includes limitless storage, point-in-time restore and recovery for your data, pause and resume for your clusters to manage your cost and total cost of ownership, as well as acceleration for SingleStore Managed Service to be the fastest database of record on the market. Our product's available on all of the hyperscalers, including AWS, Google Cloud, Microsoft Azure, and the open Red Hat marketplace. And today we're going to dive into Distributed SQL about speeding up query processing. And that's going to start today with topics on Skiplists and Hash Indexes. We'll then go through some live DDL commands where you can query directly and get your own cluster up and running on SingleStore Managed Service. To help that be effective for everyone watching live or on demand today, we'll take a couple moments to create your own cluster. So to do this, I shared before that link that we have for the $500 promotion for SingleStore. In fact, you can go to singlestore.com/managed-service-trial. And then you'll be able to see over here how you can register and check out our product. Once you register for the product, I'm just going to check if my screen is showing. That should be in full screen for everyone. If not, just let me know through the chat. Once you're registered for the product, you can then create your own cluster. So how can we do that? We'll start by going to portal.singlestore.com. And once you're registered and signed in, for your account, you can create a new cluster. I'm going to walk everyone through that right now. And then as that provisions, we'll get into the nuts and bolts of under the system Skiplists and Hash Indexes. Then we'll run some queries together. So when you're signed in to portal.singlestore.com, you can go in the view and click on the Create Cluster button. The Create Cluster button may be in a couple of different places. And when you create that cluster, there's a few different toggle knobs that we're going to adjust those settings for. First, I'll give my cluster a name. So in this case, I'm going to call this July 6th Query Processing Webinar. And I'll leave my traditional settings here for myself as proof of concept, for yourself as the trial. I'll provision on AWS and pick a region that works. For me, I'm on the East Coast out of New York City, so I'll pick the US East 1, North Virginia. And then I'll select some cluster sizes. In this case, I'll upsize from S00 to an S0 cluster size. And I'll select Next to get my cluster up and running. For an admin password, I'll generate a strong password automatically and copy and paste that to my clipboard so I can use when we access the cluster in real time. For the purposes of the webinar, I'll select Allow Access from Anywhere, and I'll have an automatic expiration after a few hours. For yours, that's optional. You can pause and resume or terminate after the webinar at your choosing. I'll select Create Cluster, and then I can sit back and in less than a couple minutes, we'll have a fully functional SingleStore cluster to work with for our webinar series today. Now, while you're getting that up and running, no worries if that takes a few minutes. I'm going to take us back into our presentation as we uncover Skiplists and Hash Indexes, and then we're going to run some queries together to see how simple it is to build your own tables and to run queries with them in SingleStore. Now that I'm back in full screen, I'm going to dive into more about the under the hood technology of the different query processing accelerators, including our Skiplists and Hash Indexes. To start, Indexes are very important to accelerate running queries on any distributed ledger. And SingleStore is a distributed system of record where, for your columns and rows, you can use indexes to accelerate your query processing. Some common SQL that you may be familiar with do include where clauses, group by, and order statements that often access different elements of your SQL tables. Often you'll even run join clauses that add more complexity to the SQL operators. And all of these commands can use indexes to quickly access pointers and record references for faster performance when running multiple queries in parallel. The first primary index that SingleStore has by default is known as the skip list. The skip list has a similar efficiency to the binary trees often seen in many SQL programming packages. Skip list has a log O acceleration for how it scales in memory. And in fact, on our distributed ledger, skip lists run often 10 times faster than the traditional binary trees that you'll see in other distributed SQL systems of record. How does skip lists work on SingleStore? In fact, skip lists start by accessing your data points. So here we have a reference of different data in different columns and rows in a table. And in this case, if you want to build the skip list index, the skip list is asking for different locations or references of the data points so it can efficiently access them for speed. What this looks like is as follows. The skip list query algorithm starts by finding a record for an index. So in this case, perhaps that record is 4 or IV. So if the number is discovered for that record, it returns the record pointer, and that's accessible in memory. If that's a no, then the algorithm continues to sort until it finds its ideal value. So in this case, it will move down into the skip list and see if now is the value greater than 4. If yes, it will continue its search through the stack and do that until it finds the exact value in the exact row that's necessary. And otherwise, it will continue moving through until it either returns a true statement or returns a null statement. That's the simplicity and the beauty of the skip list algorithm. Let's look at that in action with a few different examples. First, here's if we're looking to find the number 11. With a cursory view of this visualization, you may be hinting that there is no number 11. So we'll start from the beginning and access across to see if the number 11 is present. In this case, in fact, the number 11 is not present. We skip beyond 9 to infinity and say that this value is not searchable in the current stack. And this will continue for every value so that we'll have these metadata references in memory. If we're looking for the number 10, we'll start from negative infinity and move on and seesaw back and forth through the data, parsing until we get to a value of 10 if it exists. And in this scenario, we end up at 10 after oscillating between our lower and upper bounds of 9 and upper infinity. So 10 does exist in this data table. And this same process can be applied for different values such as 9, which we quickly search through, 8, which requires some oscillation back and forth, moving between lower and upper bounds until that data record is achieved. And this can be continued with other numbers. We'll show one final one for a demo. We could look at that with the number 7 and see the same search behavior from negative infinity towards infinity, that motion moving back and forth till we start centering in on where 7 would exist as a record. And when it's discovered, that pointer is stored in memory. So that's what a skip list does. It allows for quick access in your group by clauses, your order by clauses, your wherebys, and your joins for the specific Boolean conditions, these true or false values that you're looking to parse or access in your quick and your long-running queries. That's our first index that we're looking at today, skip list. Let's also look at a second index that speeds up the SingleStore compute engine. This one is known as hash index. Hash index is also very valuable for query processing in the query engine. The hash index looks at a value with the pointer to record. So this hash function is looking through different buckets of data and seeing where the value exists. So we had, for example, the number 7 on our previous slide, and that was discovered at a specific part of the stack. The hash index would note that 7 exists in several different data records or partitions of the stack to quickly access that data when running any of your queries. Now, there's a unique function that is required by the hash index. And this is that the hash index only works exclusively with equalities. X must equal Y. There's no greater or less than that exists here. The hash index is a powerful way to index. In fact, hash indexes do have default locations that they're used in SingleStore. And some of those common locations to apply these skip lists or hash indexes include to existing tables. If you already have a table in memory or on disk, you can add an index to that existing table. There's the DDL command to create index, where you can add that index on the table using hash as an operator. These indexes are supported on Columnstore tables, your hash indexes. They're also supported on Rowstore tables, your skip list indexes. It's important to note that these indexes are on the table level, not on your keys, whether those are primary, unique, shard, column store, or full text indexes. And similar to adding an index, this is something that you could have as temporary or for long term. You could always drop your index with the drop index command, and this can be done on both the Columnstore and Rowstore tables. Today, SingleStore does operate with universal storage. So in fact, by default, you can have a Columnstore as your data table of record for your data-intensive application. So as we'll see in our lab momentarily, you can choose to create a Rowstore when that identifies with what your data architecture team and your DBAs think will provide the most robust performance for your dashboard or your application. So we're going to now take what we've just discovered with skip lists and hash indexes and apply this to a lab together. Now, as a reminder for this lab on skip lists and hash indexes, you will need to follow along with your own cluster on SingleStore Managed Service. Now, to do that, I'm going to show you once more how you can provision your own cluster, and then we're going to be able to run some DDL commands together. One cluster question that I see in the Q&A from Jay is about what do the cluster sizes mean? And they mean about the sizing of your compute that you have available. And I'll demonstrate that actually for everyone right now again. So as I exit from our full screen presentation, back to our portal. So if it's your first time, you can go to singlestore.com/managed SingleStore-service-trial. If you haven't created that account yet, I'll also share that link for everyone in the chat, so you'll be able to check that out yourself. So feel free to register if you haven't. And once you've set up your account, you'll be enabled with the $500 of free SingleStore Managed Service credits. And then in your portal, you'll be able to go and create a new cluster. So depending on your view, I'll show a different view here to also create a cluster. In this view here, by default, I'll see that I have clusters that are available. If you don't have clusters available, you can either create the Create Cluster button, the purple button at the top right, or you may have a view in the middle that lets you create cluster. So by creating cluster, I can set this up on SingleStore Managed Service. I'll give this one an additional name. So I'll call this July 6th Query Processing Webinar number 2. And once I have all my settings correct, as I prefer for my compute, under cluster size, you can edit, and you'll actually see available for you the amount of virtual CPUs, storage, RAM in memory, and the general price that would be associated for you. For this lab, a single 0 is fine, since we'll have enough storage and compute to process any of the queries that you may like to run here today. And then you can keep this up and running if you'd like to try on some more queries beyond our webinar. Now, once that's completely live, there's a few things I'll show you for the navigation in the portal. You'll see here a green bar that will mention that your cluster's been created and is successfully online. And there's some exciting features we have available for you. First, we have interactive tutorials beyond this webinar where you can try on creating different pipelines and data-intensive applications. We have solution guides to brief you as well, and the self-paced training on training.singlestore.com. Every cluster will show some of its unique features, such as the location or region that you launched it at, its size, which you could actually edit and upsize in real time for your compute, as well as the latest version of the product. We launched version 7.5 in June 2021, so we have our latest version of SingleStore database engine on a SingleStore managed service available. And you could also check some of our guides for loading data from different cloud providers and connecting from a CLI or your preferred IDE for running SQL queries. For the purposes of today's webinar, we're going to navigate from the Overview tab through the Monitoring tab. The Monitoring tab has a location where you can open SingleStore Studio. SingleStore Studio is our user interface graphics that's available in browser to not only run SQL queries, but also to administer your SingleStore managed service. Under the Monitoring tab, I'm going to click the Open SingleStore Studio button. The Open SingleStore Studio button will launch in a new browser tab available for me to sign in and access this version of SingleStore Cluster, with this version being 7.5.4. I'm going to paste my password that I copied before. And in this case, oops, looks like I may have copied one too many things. So I can go back to my portal. And in this case, I'm going to reset that password because I forgot it. So I'll generate a new strong password, copy that, reset, all reset, go back here. Let me paste that password and see if we can access that. There we go. It took just a second for that command to run behind the scenes. And now I'm live in SingleStore Studio. Now, some of you may still be getting your cluster up and running. Not to worry, this webinar is available not only in real time, but also on demand. But I'll continue to walk you through some of our settings here. And then unify that with our presentation so you can run some of these commands and gain some familiarity with the user interface as well. One question I see in the chat is if we can use DBEs or to access SingleStore cluster. Yes, any SQL IDE that you use, SingleStore is MySQL wire protocol compliant. So any of those IDs that you use across the board, they can all access SingleStore to run your SQL commands, whether those are DDL or DML commands. Okay, let me walk everyone a little bit through our navigation, and then we'll run some queries together. So once you're signed into your cluster, there's a few exciting things to see. First, we have a dashboard. This view shows all of our general information, such as cluster health, cluster usage, any running pipelines or database usage. There's a pop-up you'll see from the lower right for tutorials. So we have some fantastic tutorials that you could try beyond the webinar to query data sets. And we'll actually, when you go through these tutorials in real time, we'll have little code snippets that you can paste and see how those work in real time in the SingleStore managed service. And there's some of those from querying data, loading data among cloud systems and on-prem, as well as building applications such as a stock trading app or an advertising tech dashboard. For the purposes of this webinar, I'm just going to X out or minimize that information for our future reference. And I'll show everyone a few more things before we get started in the queries. Through the SingleStore Studio, you can also in real time view any events that have been occurring on your cluster, the status of your different nodes. In this case, I chose the S0 sizing, which provided me one master aggregator, which is a control plane for my cluster, and two leaf nodes or workhorses. These are where I'm going to execute any DDL commands across different partitions for my databases. And if you have multiple databases, you'll be able to view them directly from the database's navigation. Under the query section of our navigation, we have the SQL Editor. This is where we're going to be running queries here today in just a couple minutes. And then there's some administrative sections such as the workload monitoring. If you wanted to see how a query ran and if it was optimized to your expectation. You could view active queries if you have any long running queries. We see here the standard query to view the health of our cluster. And our visual explain tool for different queries. You can see how they're defined and how they're processed across your cluster. For this lab, we're going to move back to our SQL editor and we're going to run some queries. So first, I'll take us back to our presentation and show you where we can learn more about our queries that we're going to run. So for today's lab, we have a few queries, and these queries are already available for you on a public GitHub gist at the URL bit.ly/SingleStore2. So if you go to that URL, and I'll share that for everyone in the chat as well. This URL will bring you up to our public GitHub gist. And here there's already the sample code that we'll be working with for the next few minutes. So you'll be able to see how you can create these queries with row stores, column stores in our SQL editor. We're going to code and run a few commands here, so you'll be able to see both skip lists and hash indexes in action. One question coming up in the chat is about these indexes. When do you use them? Can skip lists and hash indexes be used both on row stores, and on column stores. So there is something really unique here, and this is that in general, hash indexes can be used on both Columnstore and Rowstore. Skiplists would be only used on Rowstore. So that would be the distinction there of the hash index and the skiplist index. And we're going to go through those together now. So for this portion of the lab, I'm going to split my screen in half. On one side, I'm going to have the SingleStore Studio. And on the second side, I'm going to have our GitHub gist code. So similar, you're welcome to follow along in real time. We're going to start by creating a database. So I'm going to create a database. And we have the command if not exists, since this is a new database called DB Training. I'll finish my command with a semicolon. I can run that with Control-Enter to create that new database. Once that's finished, I can write the use DB Training command to select this as our default database of record. And now we can work with creating both row stores and column stores. So our first table, I'm going to actually copy the code for consistency. We'll have here a row store. So the first code here, what makes this a row store? As of version 7.3 from December 2020, column stores are default in SingleStore. So to have a row store, you do need to select the optional row store command. And now we have a row store available that we can run in memory. This here is referencing a product table that you may have for a SaaS platform or e-commerce business. And beyond all the different features for these products, you'll notice what makes this unique to SingleStore is a few things. First, there is a shard key. The shard key is our distributed ledger technology for processing queries across multiple leafs and multiple partitions on a record-by-record basis. There's also unique keys set here, one for supplier ID and one for category ID. As this here is our row store table, by default, these will be our skip list references here along with our keys. So in this case, I'm going to highlight this query, and I'm going to run it into memory with Control-Enter. I'm going to go back to full screen just for a moment here. And I'm curious to know what happened once I ran this command. Well, as mentioned, we can go on the left, in fact, to our databases reference, and here see that the new DB Training reference has been created. In fact, there's one table, this row store table, and it can access different partitions. I'll click into that database and I'll see the products table is available. The storage type is a row store. There's a lot of other excellent navigations available depending on my queries. For this scenario, I'll click on products and I'll see all the metadata about this table, including the columns that we set and any indexes. Notice how these keys have been made indexes for category ID and supplier ID. And those indexes for the row store table will be known as skip lists. We have our shard key or our distributed technology key for product ID. And that's what we have in this scenario with the row store. So that's our first example that we're going to look at. We're also going to look at a second example. Before we do that, I did want to mention there is sample data. If you have data, you can view that here. And there's also the SQL, so you can see what was created and how our smart engine ensured that you're able to bring this table in with all the statistics to help speed up your row store table for ideal performance on SingleStore Managed Service? Great question here. Yes, if you do not select a primary key is created by default. That is true. And so in this case, that product ID here became both our shard key and our primary key. Okay, I'm going to now split my screen again. We're going to go through one more example together. I'm navigating back to my SQL editor, and I'm going to scroll down, and we're going to do an example on Columnstore. So Columnstore traditionally is for analytical workload, big dashboards, on-disk memory, could be, billions or trillions of rows of records. And in fact, because workloads continue to scale for data-intensive applications, our SingleStore product and engineering team chose to make Columnstore default as a version 7.3 in December last year. And we're going to see now the distinctions with our Columnstore from the Rowstore before. Here I'm going to copy that code as well, and feel free to also access this just with the link I shared in the chat, so you could try that out in the real time as well. So what's unique about this table schema? As I navigate back to full screen, what we'll see is we're creating a table course ratings. We're not naming it with Rowstore or Columnstore, since Columnstore is by default. We have different features here, and the unique ones I'm going to have us focus on is first the shard key. Again, this is the distributed technology to move different rows or records into different partitions to run your query as a distributed nature. It's also been selected with 2 hash keys on course ID and user ID. So anytime, for example, the course ID 7 shows up, we'll be able to quickly reference and point that because the index's metadata will be available in memory. This example also has a full text index. This is another index that was not covered during today's webinar, but is another option if you're working with natural language processing, natural language generation, or any type of text search for your database. And to make this our column store, we're also using what's known as the clustered column store key. This is another accelerator for column stores. What this does is it quickly accesses all the rows or records in your table, and it identifies unique buckets of 1 million records at a time, sorts through, and holds memory reference for the unique values to compress storage. And this is a significant storage boost that can provide anywhere from 3 to 1,000 times performance improvement, which is heralded as the universal storage breakthrough that's led SingleStore to be used as the database system of record for many of the Fortune 500 today with this column store technology. And so that's the unique part for Columnstore. I can now run this command together. I'll highlight it and press Control Enter. And now I'll navigate back to my databases, and I'll see now that it's automatically refreshed, and I see I have 2 tables available. And when I click on DB Training, I can see the new course ratings table has been made available for me. And when I click in, I can see additional metadata about this table, including all the feature columns and our indexes. In this case, the column store hash has been created on course ID and user ID as we've requested in the DDL command. And there's the shard key, which is available on ID, and the clustered column store key that was made as well for compression. And lastly, the full text search for our other indexes. And we do have indexes on full text and geospatial data as well, beyond the Skiplists and Hash Index accelerators that we've seen today during this webinar. Now, there's a few more things I'd like to share with everyone. So as a reminder, we just spun up SingleStore clusters. If you haven't done it yet, take the opportunity on to practice it, to use our managed service product on the cloud. It's exciting to see how you can quickly spin up a cluster and run your SQL commands. You're welcome to keep your cluster up beyond our webinar today. I mean, you may have $500 of credit to try running different data-intensive applications, or even practicing our tutorials. I'll show you back in our studio. As a reminder, we do have this question mark button, and this does allow you to access some of those guided tutorials. And these have been built up from our solution engineering team and our core product engineers. And they give you some great examples that can help you see the possibilities to unlock with SingleStore. A question here coming up in the chat is, for a column store table, is a primary key required? No, primary keys are not required for column stores. They're not created if you haven't selected one. Okay, with what we've covered here, we have a quick review. We've been covering so far skip lists and hash indexes, and looking into these Columnstore and Rowstore data tables. Well, what I'd like us to look at now is to understand, when do you use an index? What are the best use cases of an index? So we've discussed here a few of those today. I've mentioned some of the locations that you would index on. Let's see what you recall with our real-time knowledge check poll. So here's our poll that we can run here together. I'll tell you a little bit about how this poll software works. So there's two ways you can respond to this poll. You can either go to pollev.com/DavidY075 and respond to this question in real time, or you can text DavidY075 to the number 22333, join the poll, and then provide the answer choices that you think might be possible, A, B, C, or D. There could be also more than one answer available here for this poll. So take a moment. What type of columns would you create an index on based on what you've been hearing today? Would you create it on A, columns that you're aggregating on frequently, B, columns that are frequently used in where clauses, C, columns that have high cardinality, and or D, columns that are frequently joined on? So take a moment to connect to the poll. And now we can see some of the responses in real time. I'm pulling up the live answers that everyone's providing. So let's see what people are thinking. Okay, it looks like we have interest in A, B, and D, and it could be multiple of these are correct. I will tell you that you all stumbled on something. C is definitely a distractor. It's not one of the answers here. I never mentioned the word cardinality during today's session, so definitely C is not correct. The correct answers here, thank you all for your participation, by the way. The correct answers are B as in Bravo, and D as in Delta, B and D. Frequent clauses such as these where, group by, order clauses, that's B as in Bravo, and D as in Delta for the join clauses between multiple tables together. That's how indexes will accelerate your query performance and the processing. A is the distractor as well, because if you're frequently running aggregations on the columns, well, that means that you're going to be having changing data for those columns. That means your indexes will not be up to date. You're going to have to rerun those indexes, have the latest data stored to access. So A is actually a detractor. In this case, Bravo and Delta were the correct answers. Thank you all so much for that participation. I hope you found that rewarding and fascinating as well. Okay, and now we're going to move on to a couple other topics here today. And then I'll open it up for some additional Q&A. Universal storage. So what is universal storage? Universal storage is the evolution of SingleStore. SingleStore has been around as a product now for going on 10 plus years. We just celebrated our 10th year anniversary, and that's where universal storage, the coming of age of a database as a system of record for data-intensive applications, has been made possible. Universal storage has been seen as the integration of OLTP, or your transactions, and OLAP, or your analytics, into a hybrid transactional and analytical processing system, which is SingleStore's universal storage. We're one of the few HTAP providers on the marketplace today that make it accessible to have a low total cost of ownership for large databases. These are going into the trillions of rows. These are going into the yottabytes of data. There is limitless storage that you can run for any application on SingleStore. There are no limitations on compute with RAM. I mean, we have clients who go into beyond the terabytes of RAM for some of their applications. And you can access fast lookups and scans powered by Skiplists, Hash Indexes, and other distributed ledger technology that we've gone under the hood with today in this webinar. SingleStore today has gone from a dual store to a single store. It's a simplified architecture. There's no more ETL, there's lower cost, there's less latency through this universal storage architecture built for the best of both worlds, OLTP and OLAP. Today, SingleStore is used with Fortune 500 clients and scale-ups alike for fast applications, fast analytics, and for fast ingest and CDC with data pipelines. We have a lot of exciting events coming up at SingleStore to help you learn more about our product in the marketplace and to scale up on your education learning. Later this week, we'll have a modernization to migrate from PostgreSQL, and we have other webinars coming up throughout the month. Be sure to check them out. You can register in singlestore.com/events. And as a reminder, before I open up into our Q&A for today's session, you can learn your way. You can read more on docs.singlestore.com. If you haven't already, you can sign up at singlestore.com/managed-service-trial to get $500 of credit to spin up your own managed service trials. And you can check out our community forums, our YouTube, our training site where we give badges for completing your developer training. Check out our LinkedIn now. There is new developer and administrator badges, so you can get some digital swag to show off your credentials and celebrate your achievements for learning SingleStore. And for any other questions, we do have our Zendesk, the MemSQL Zendesk. I'll bring that up briefly right now. We have an exciting knowledge base. These are with some of the common questions from our Fortune 500 clients anonymized for how to be successful on SingleStore. Everything from our new announcements to FAQs on SQL, the engine, replication, cluster sizing, storage, pipelines, backup and restore, upgrades, our new drivers, and more. There's a lot to learn as we welcome you into the SingleStore family. So with that, I'd like to reopen it up. I'm sure there's some more questions you may have from our lab and from the topics that were covered today. So feel free to ask any questions in the Q&A, and I appreciate everyone for your participation. Great question here in the chat. The question is saying that if you have a where clause which references two columns, one which is a hash index and another which is the clustered column store, which index will be utilized? So the clustered column store, this is a default selection that you create upon creation of a column store table. This accelerates the performance of storage and accessing any point throughout the cluster column store table. With that said, the hash index has a specific use case for a unique value, true or false. So in this case, both are accelerating your query performance when you're running with a SingleStore cluster. So they each have their own unique case. The clustered column store is unique to Columnstore, while hash is an index that is available on both Columnstore and Rowstore. Great question here. Yes, the recording of this session will be available online. It's available on demand. And if you have other questions as well, I'm going to share my email into the chat. You can always reach out to me directly. We can share the recording and any additional questions you have on the product. Happy to look into that for you as well. Well, everyone, thank you for taking your time here today to learn more about SingleStore, about distributed SQL. This has been a primer on query processing. My name's David Jakobovich. I'm with our education delivery team. For any additional questions, you can reach out to me directly. You could also check out singlestore.com/events to see all of our upcoming webinars and about the $500 of free credit for your SingleStore managed service trial. Thanks all so much for joining us, and we'll see you at the next one.